My name is Sasha. I am a security engineer on the detection and response team at Remitly, which is based in Seattle. I have done a few different roles within the security org. I started off doing user security and trust and safety, and then I spent a few years doing vendor risk management and governance, risk, and compliance. And then I've spent the last 3-ish years in detection and response. And today I'm going to talk about easy mode deception technologies at scale. This is something that I've been working on only for about the past 6 months, so you'll see how much progress we've been able to make really quickly. So first off, what are honey tokens and what is deception technology? Deception technology is a type of tech that helps incident response teams detect, analyze, and defend against attackers by enticing them to interact with fake IT assets deployed in our network. There's 2 different types of deception technologies that I've been working with. One is honey tokens and the other is honey pots. Similar, but just a little different. A honey token could be a set of credentials, a Word doc, or a domain, whereas a honey pot is a fake infrastructure resource like an EC2 instance or a container that's created and positioned within our network, potentially alongside legitimate network infrastructure. There's a lot of benefits to deception technology. One is that when they're deployed correctly, they provide really high fidelity alerts. If they're not deployed correctly, then you're going to have a ton of false positives, and so we'll talk about later why it's really important to place them correctly in your environment. They provide good risk mitigation for areas of the environment that don't necessarily have other detections deployed on them. So if you are an early stage detection and response team, or you don't have the budget for a full EDR tool, but you want to have some coverage on your endpoints, it's much easier to deploy some honey tokens on your endpoints than deploying a full EDR tool across your environment, and that can give you some coverage for potential bad actors on your endpoints. They also help you identify suspicious activity early on in the attack chain. Again, if they're placed correctly, it'll potentially alert you that an attacker is active in your infrastructure before some of your other detections go off. They misdirect attackers towards useless information and waste their time, which is always good in giving you some extra time to discover that they're there and stop them before they can cause any further damage. They provide information about attackers when the tokens are used or when the resources are accessed. So I'll show you later on, there's some tokens that if they're used, they'll provide valuable information about the attacker's infrastructure, like their location or their user agent. And they also can show you what areas of your environment that attackers are interested in. So if you deploy 10 different types of honey tokens on a resource and you see that one type of token is consistently accessed, then you know that's probably the area that you need to shore up defenses on. They also provide enhanced incident response capabilities for when the tokens are triggered because of that data that you get from about the attacker's infrastructure when they're triggered. So they're so awesome. Why doesn't everybody use them? Because there are a lot of challenges with deploying deception technologies at scale. The first question is, where do we deploy them? We probably know approximately what our network topology and corporate environment looks like, but from a time perspective, we can't deploy tokens on every single IT asset that exists in the environment. Like, think about a knowledge repository like Confluence. You don't want to put a Canary token on every single Confluence page or every single Google Doc, because that's just going to take a lot of time and probably not have a good return on investment. The second question is, how do we deploy them? We need an automated method that tracks deployment errors for the existing environment and has handling for when we add new assets to the environment. This has to scale to the entire deployment stack. How do we make them? These tokens need to be attractive to attackers, but they also need to contain links back to our Honey token dashboard for monitoring when they're triggered. If we just make a random doc that says, honey token.doc, it's probably not going to be accessed. It needs to look like something valuable. And then how do we respond when they go off? So say you've reached the point where you get a token on all of your IT assets and you have this centralized dashboard for monitoring when they go off, but your analysts need to know what to do when those go off. So we need playbooks, we need action plans for different severities of tokens, and we need some sort of automation, ideally, for responding to different severities of tokens. So enter in a tool called Thinkst Canary. Thinkst is awesome because they have some free resources that are available for deploying tokens. Last slide, I talked about the 4 main challenges of Honey tokens. So that was where to deploy, how to create them, and how to respond to them. And Thinkst helps us with each of these problems. Thinkst makes creating a token as easy as point and click, which I'll show you. They also provide some open source scripts for deploying tokens onto large numbers of assets within the environment and pointers for useful methods of deployment. They have a bunch of different types of tokens that you can deploy in Mac, Windows, Linux, and the ones that I'm going to show you are Honey tokens, not honey pots, which they also provide. So a fake container or EC2 instance, that's also an option, but those are paid canaries from Thinkst. You'll see how easy it is to create a new token and test that the token is working, and also some intel that's gained against an attacker when they click on the token. There's some cool customizations and flexibility that's available, such as where do we place them, what we name them, what the contents of them are, and where they redirect to. So here is me creating a new token. So I'm just showing the different types of tokens that are available on the free Canary Tokens website, which is canarytokens.org. And one that I've found pretty simple to use is the QR code token, because all I have to do is put in an email and name it, and then it gives me a QR code that I can download and I can ship off to all of my endpoints and save it as something like MFA backup, and now there's a canary on our endpoints. So I want to show you what happens when if I can get to the next slide. What happens when this token is triggered. So using my phone, I just scanned that QR code, and then I have this email that I set up, and the email showed up pretty immediately with some interesting data about who clicked that QR code. And now I can use that to add to my knowledge repository about the attackers that are going after my end users, and potentially add some IPs to my block list. There's a bunch of different things that I can do with that data. So challenges. There are a lot of challenges with deployment. The first question that we have to ask is, what will be the impact of widespread deployment of a new technology on our existing security infrastructure? So some considerations here. If you do have an EDR, you might get alerts from running the scripts that you need to call to deploy the tokens. There's a Windows token that alerts for sensitive commands being run that modifies registry keys. So that will probably trigger an alert in your EDR, and you need to make sure to have an allow list for your Canary tool before you run that script. Otherwise, you're going to have a ton of alerts. You have to think about false positives and user confusion that could be created by deploying the tokens in a place that's too visible for end users. So think putting a dot called secrets onto end users' desktops. People are going to see that one day and be like, what's this? And probably open it. And then now not only do you have a ton of false positives, but you also have kind of defeated the purpose of the tokens because now everybody in your company knows that they exist. Probably the biggest challenge is, at least with assessing impact, is are you going to overwrite actual user data causing harm to productivity? So think about an AWS API key token, which is going to be really attractive to attackers, and you probably want to put it in a place where it's going to be seen and targeted, so maybe the AWS config file, but you don't want to overwrite someone's actual AWS config or you're going to cause a lot of problems. Another consideration is costs. So are you going to buy things, or are you just going to use the free version? Either way, you're going to have some engineers that are going to be deploying and managing the tool. And then if you're creating the tokens yourself, you have to think about infrastructure cost. There could also be some concerns from stakeholders, so IT and infra teams. To deploy these tokens across your environment, you need a lot of access. And there's not much that you can do to mitigate this except for to use a secure development cycle. So make sure that every deployment and change to deployment settings for the tokens on endpoints is codified and requires consensus, and ideally from a system that only allows pushes to production from trusted environments. So our practical steps and best practices for efficiently deploying a single token to many devices across the environment. The first thing that you should definitely do is start with a proof of concept. So one token on each different type of device that you're testing, ideally in a test or pre-prod environment. So maybe you put one token onto your test VM, and then after that, you can move on to your security team. Is a really good group of users to start with because those folks might already know that this project is happening. And like I said, you don't want too many people in the organization to know that you're deploying this technology, or it's not going to be as useful. So you deploy to your smaller set of your smaller group, but you don't give them too many details, and see if there's any performance issues or if the token shows up in places that it shouldn't be. Monitor your false positive rates as you deploy to this larger group. For S3 tokens, there could be some automated processes that are accessing S3 buckets, and you want to make sure that you're not creating an alert every time there's a robot action accessing the bucket. You only want to know about attackers accessing the bucket. For endpoint tokens, we changed the visibility settings and put tokens in hidden folders to lessen the potential discoverability by end users. And then we also had to think about which tokens make the most sense for different environments. We don't want to attempt to deploy the Windows sensitive command token onto Macs because that'll cause errors. Another challenge that we had is how do we do the deployment? So do we use EDR or MDM to automate and streamline the deployment process for multiple endpoints? So I started with EDR because I'm on the security team, so I already had access to that tool and I already knew how to use it. And I knew that I would be able to use the tool to run scripts on my endpoints to deploy my tokens. But anyone who's used EDR probably can guess that it wasn't the best solution because it's not really intended for that purpose. This is really something that you should use MDM for, because with MDM you have better state management. With the EDR, I had no state management at all, and I tried to kind of hack something together, but it didn't work. And then I tried to manage state myself with a local database, and that was also too complicated. Versus MDM, I just had to get access and learn how to use the tools from the IT team, and then all of a sudden I not only have good state management and I still have the way to deploy the scripts automatically, but I also have an automated way to decommission tokens from old devices and add all my tokens to devices the second that they're spun up in the environment. So we're not quite at this place yet, but I know what the ideal automated endpoint solution would look like. And it would start with your engineer makes a change in their coding tool, and they submit that to the code repository that another engineer has to +1 to. That goes to your infrastructure tool where you have some automated function that's listening for new updates to the code repo that contains all of your token scripts. That also contains your state management database, so you can say what devices are supposed to have the token and which ones are not, and which devices are new and which ones have been decommissioned. There's also error handling, which we'll talk about after. But so you go, once you receive the update from the code repo, that would send a push to the MDM tool, which then deploys the script to whichever devices don't have the token already on them, as managed in the state management tool. And then in MDM, you push to the device. The device goes back to the MDM and says, yes, I've received the token as expected, or no, your push didn't work. And depending on that response, you go back to your automation tool, which has a module for error reporting. And then from the error reporting, you can send out alerts to your detection and response team that something isn't going as intended. Once this entire state, this is the automated deployment state, but even before you get to this point, if you're deploying tokens to endpoints, you need to have a way to respond when those go off. Like I said earlier, you don't want your analyst to be receiving alerts and have no idea what to do with them. So, response. You have a few steps in the response process that definitely need to happen. So, if you have a SIM, you should send all of your alerts that come from Thinkst or wherever else you manage your tokens to the SIM. There's some magic and context that gets added to all of the events. So in an ideal world, that context could tell you if it's a false positive or a true positive. And if it's a likely false positive, it'll be lower severity than a true positive. From your SIM, you go to your ticketing tool, and you also have your playbooks, which tell the responders how they should respond to the different types of token alerts. And then depending on what context is added, you might want to reach out to the end user to see if they accidentally triggered the token themselves, or if you suspect from that context that it's likely a true positive, you can send a command through MDM to lock the endpoint or decommission the infrastructure, declare an incident. Some sort of automated response is always ideal. So what's next? Canary tokens is a really easy way to deploy deception technology, but you will have scaling issues. And so that's why I do recommend them as a way to start, because they help solve some of those first round problems that you're going to have with deploying these tools. And once you've deployed to a single host, make sure that you deploy to a small group of hosts before you try to deploy to your entire environment. Don't deploy to the whole environment without monitoring for your false positive rate. And make sure that before you turn on the tokens in production, you have your response steps laid out, whether that's manual playbooks or automated response actions. Thank you.
We have a couple minutes. Any questions?
Hey there, thanks for doing this talk. One of the things that I worry about for something like this is you really want to hide all of your tooling and all of your infra from an attacker. So what do you do so that they can't just easily find everything about where your Canary tokens are?
You mean hide it from end users, but not make it visible to the attacker, but not to users?
Sorry, let me clarify. So let's imagine an attacker is inside your company. They've breached in some way. Like, one of the things they might want to look for is, oh, what are they doing by the way of detection engineering? Like, how?
Yeah.
So what do you do to kind of quell the fear that they're going to find your Git repo with all of your configuration and code and everything?
Yeah, that is a really good question, and definitely something that we've had to consider. We try to use code names wherever possible and not name anything Canary or honeypot. But at the end of the day, if they're in the environment, we just want to make sure that they find the token first before they find our DNR infra. So it's like, if they think that this looks juicier to target, then we might have some time before they get to a more important part of the network to kick them out.
Thank you for the talk. I think it's more of an art than a science. I think that there's a lot, it's a game that's being played between both the adversary and the people inside. Have you considered things like synthetic traffic to cause tokens to be in caches, to make it look like they're actually being used? Because if people see files that are not being touched surrounded by files that are, right? Things like that. Are there more adversarial type, not adversarial, aggressive ways of kind of making it juicy to draw people's attention?
Yeah, that's a really good idea, and honestly, not the step that I'm at yet. I would say we're still at the place of how do we just get these endpoints or these tokens on all of the endpoints and in all of the places that we want, and make them look at least attractive. And then the next step is to make them even better, which I think that would be.
I got another question for you. If you want to have a Canary token for AWS, awesome. If you're looking at a situation and you've got I've got 10 third-party API tokens and Canary tokens doesn't support them, what do you do then?
Yeah, then you get to the place of trying to create your own tokens. So, there are I think that Canary helps you learn about how tokens can be deployed, and you can learn, okay, the way that the S3 token works, for example, is it uses the AWS S3 logs, and then you create a second bucket, and then you get an alert whenever there's a new event to that bucket because there's been an access event to the bucket that you're monitoring. So once you know how it works under the hood, which you can see on their open source GitHub, then you can try to deploy some of these things yourself. I think that's just where you get more of the infrastructure cost that you won't have if you use things.
Hey, Sasha, thanks so much for your talk today. This was awesome. I'm curious what metrics or data you're collecting to show the effectiveness of the Canary tokens as a detection mechanism versus your traditional, threat detection patterns.
Yeah, totally. So we don't have a ton of metrics yet besides false positive rate and also the success rate of deployment. But once they are fully deployed, beyond false positive rate, I think it would be really interesting to see if we do have metrics on security incidents, how many times were the tokens involved in that incident versus were they just completely ignored. And if we know that an endpoint was compromised and the token was ignored, then we're probably doing something wrong and we need to revisit it. Cool. Thank you.
Thank you, everybody.